Welcome to Btechnical. This lecture is in continuation of Foundation Engineering of Lecture 5, that is a revision lecture. So as you know, we have started a revision lecture of Geotechnical Engineering. This is last part of Geotechnical, that is Foundation Engineering. In view of Bpsc, AE, advertisement number 29 by 2025. So we have already discussed the shallow foundation and the related things. In this lecture we are going to discuss the deep foundation, that is pile foundation, and the other things. There is a test in pile foundation called as standard penetration test, standard penetration test, in short SPT. So SPT, when you are going to conduct, there is a parameter called as n values, that is number of blows. So if the soil has high SPT value at shallow depth, then there must be a correction that is called as overburden correction. Overburden pressure is the pressure due to soil. So due to this overburden pressure, this value may increase. So we need to reduce this value by this correction, that is overburden pressure correction. So this is equal to N1 is equal to N0 into 350 divided by sigma naught bar plus 70, where sigma naught is the effective overburden pressure. Sigma naught is the effective overburden pressure, and 350 70 is the standard value, and N0 is the observed value, observed SPT values. So N value, observed value is N0. Based on this N0, you can calculate this N1 value, and after that there is one more correction which is called as water table or dilatancy or fineness correction. This is needed because of sometime below water table there is fine sand or silt, which also increase this N values below the water table. So you can calculate this N2 value, that is equal to 15 plus half of N1 minus 15, where N1 again the corrected N values of overburden correction factor. So from this you can calculate this N2 value, and this N1 and N2 value is the overburden as well as dilatancy correction factor. Now next is we have two methods to calculate the end bearing pressure of pile, that is static method, also called as analytical method, and other is dynamic method. So first we discuss the formula associated with static method. This is for either end bearing pile or friction pile. So for end bearing pile, if the soil is clay, then QUP is equal to QB into AB plus QS into AS, where B suffix is used for bearing and S suffix is used for surface. So in case of clay, this QUP is called as the ultimate bearing pressure of end bearing pressure of the pile. So QUP is equal to NC into AB plus alpha C bar into ASF, where AB and ASF you need to calculate. So AB is the end bearing pressure. If the section is circular, then it is pi by 4 d square, and if it is square, then simply whatever is the age of this square, the square of this age, right? Suppose square size of B, then it is B square. And for surface area, you can calculate that perimeter pi d into the length of the pile, that is L, and in case of square shape, it is 4b is the perimeter into length of the pile, that is 4bl. Here 9c and alpha c bar is the value of qb and qs. Okay, and c bar, alpha, these are the friction factor. This term is associated with the friction. This term is associated with the end bearing. Okay, so these values are given in the problem. Next is, if the soil is sand, second part, if the soil is sand, then formula will change. Here QUP is equal to gamma L NQAB plus half of K gamma L 10 delta into ASF, where this gamma L into NQ is nothing but sigma bar into NQ. That means sigma R is equal to gamma into L, and in this case this 1/2 K gamma L into 10 delta, this is nothing but K sigma bar into 10 delta. 10 delta is the friction angle, and this K into sigma bar, in which K is the lateral earth constant. Okay, so from this formula you can calculate the QUP values for sand. Next is the dynamic method. Dynamic method is generally suitable for sands, as clay results loss of shear strength, because of when you conduct the dynamic experiment, then because of dynamic action this clay results loss of shear strength. So it is generally preferred for sand soil, sandy soil. There is two formula used in the dynamic method. One is engineering required formula, engineering news record formula. Other is modified Haley's formula. Okay, so in engineering news record formula, QUP is equal to WH into S plus C. Okay, where W is the weight of the hammer, H is the height of fall of that hammer, and S is penetration value. You can see here S is the penetration value, and C is the coefficient, which is depend on the which type of hammer you have using. If the hammer is drop, then this value is 2.5 centimeter, and if hammer is a steam hammer, then it is 0.25 centimeter. So C value is like that. Now if you want to calculate the SAF SAF, means safe ultimate bearing capacity, then QUP upon factor of safety, and this factor of safety in this formula, in this case you have taken as 6. So the formula becomes WH divided by 6 into S plus C. So 6 is for drop hammer. Okay, in the same formula, if the double acting steam hammer is there, then this safe bearing pressure will be equal to W plus AP into H divided by 6 S plus 0.25, and this 0.25 value is for steam hammer, right? Where W plus AP, this value will change, where A is the area of the piston in centimeter square and P is the steam pressure in kg per centimeter square. So slight change in this formulae. Next is modified Haley's formula. So in modified Haley's formula, this is also adopted by the IS code, Indian Standard Code. This is QUP is equal to NH into NB, not NH, it is eta H into eta B. Then again the weight of the hammer into the height of fall divided by S plus C by 2. This value is C by 2. Okay, so this formula is used by Haley's. Then again, if you want to calculate the safe pressure, then QUP upon factor of safety. But in this case, the factor of safety is 3. Like in engineering news record formula is factor of safety is 6. Here is the factor of safety is 3, where eta H and eta B is the hammer efficiency and eta B is the hammer blow efficiency, right? So in this SPT dynamic method, the weight of hammer is usually taken as per IS code, this is 63.5 kg, and height of fall is 75 centimeter. Height of fall is 70 centimeter. Next is driven displacement pile and board pile. For driven displacement pile, this is QUP is equal to 4 into W into N into AB plus 2 N bar into AS. So again, all has the usual meaning, N, W, N bar. Okay, Then for board file, QUP is equal to 400 into N into AB plus N into AS. Again, these all are the QB. This is the QS. Again, here is the QB. This is the QS. The formula will remain same. Like here in the starting of this, that is QUP is equal to QB into AB plus QS into AS. So based on that formula, this value may change. Next is the group pile. So in group pile, there is some objective question may ask, that is to find the width of the pile. So if the spacing of pile group is given, suppose S is the spacing between two piles. Okay, in a row there is 3 pile, then the formula becomes B is equal to, and dia of the pile is D, then M minus 1 into S plus D. M is the number of this pile, 1 2 3. Here is the number of pile is 3, so 3 minus 1 into S is the spacing plus D, so D by 2 it becomes D. So this is 2S plus D. So B is equal to 2S plus D. Whatever be the value of this S and D, you will get the width of this group pile. Next is again the capacity of this group file, that is QUG, is equal to 9CB square into alpha C bar into 4BL. Okay, again here this B square is nothing but QB and 4BL is nothing but QS. QB. This is AB and this is ASF. Okay, and this is QS. This is QB. So in this case, QB is equal to 9C. QS is equal to alpha C bar. C bar is the cohesion, alpha is the friction angle. This all the term as already discussed. This is for clay, and for sand, this QUG is equal to again sigma, that is gamma L into NQ B square 1 by 2 K gamma L into delta, 10 delta, and this is the area. Okay, so this formula is used for sand. Already I have discussed in the upper portion. Okay, next is the safe load. For again the QUG, the capacity of group pile divided by factor of safety, you will get the safe load. And safe load may be you can directly calculate the capacity of group pile, or you can calculate the capacity of one pile multiplied by total number of pile. So whichever is the minimum of the both, you will get the safe load. Okay, and in this case the factor of safety ranges 2 to 3. Next, based on this, you can also calculate the group efficiency of the pile, that is Ng is equal to QUG divided by N into QUP, means the capacity of group pile divided by N times the number of pile into capacity of single pile. So this ratio you will get the group efficiency. So group efficiency is greater than 1 when you use this safe bearing capacity, that is NQUP upon factor of safety, and this is less than 1 when you will calculate this QUG divided by factor of safety. So it may be greater than 1 or it may be less than 1. Okay. Next part is here we have completed the pile foundation formulas and the related things. Now we discuss the stability number, that is related to slope stability analysis of the geotechnical engineering, or we can say the soil, stability of the soil. So there is a stability number given by the Taylor. So Taylor stability number Sn is equal to C upon gamma into Hc, where C is again cohesion, gamma is the density of soil, and Hc is the critical height of this failure surface, right? So if you know the factor of safety, then Hc by H is the factor of safety. In this case, Hc is equal to H into factor of safety. So become Sn is gamma upon gamma H into F. So this HF is nothing but Hc. Okay, if you know the factor of safety, you have to use this formula. And another formula is if the beta angle is given, the failure slope is given, then cos square beta into tan beta minus tan phi. So from this formula also you can calculate the stability number, Taylor stability number. These three formula used for Taylor stability number. Next is there is types of failure in this slope. One is called as face failure, that is slope failure. Other is called as toe failure, and third one is called as base failure. So these three types of failures are associated with this slope stability. That is called as rotational failure. Okay. So first we have discussed this three failure one by one. You can see in this pictorial view that the face failure occur when soil above the toe containing weak stratum. Means if this is the toe, this is the toe portion of the slab. So above the toe, if the soil has weak stratum, then the face failure will occur. Okay. So this section, this portion is associated with failure surface. Okay. This is the failure surface. So in this case, this depth factor, df is the depth factor. Depth factor is less than 1. We will discuss this depth factor also. There is some question also asked in the past that related to the depth factor. Okay. So in this case, means when face failure occurs, the depth factor is less than 1. Second is the toe failure, when this failure surface passes through this toe. At that, in this case, this depth factor is equal to 1, and this is called as toe failure. And third one is the base failure. This failure occur when this failure surface passes through below the toe of the soil stability. So this is called as base failure. Okay. So in base failure case, this depth correction factor is greater than 1. Okay. So base failure, the weak soil stratum under the toe. So under the toe there is a weak soil stratum. Okay. Now this term depth factor df is equal to h plus d by h, where h is the height of the slope and d is the depth of the foundation. Whatever is the depth of foundation, so h plus d divided by h. So this is the depth factor, and this depth factor is less than 1 in face failure, equal to 1 in toe failure, and greater than 1 in base failure, right? And the last part is sampler. So there is a split spoon sampler. This is called as steep spoon sampler. You need to remember this pictorial view, because from this view you just clear what is the area ratio, inside clearance and outside clearance. Okay. So this is the inside clearance, this is outside clearance. So how you calculate this clearance? There is a possibility to ask the objective question on this simple formula. Okay. So what is area ratio? Area ratio is nothing but this d2 square minus d1 square divided by d1 square, and it is in percentage, so multiplied by 100. So what is d2 and d1? You see here, this outer to outer, this diameter is d2, this diameter is d2, and inner to inner the diameter is d1. So d2 square minus this d2 square minus this d1 square divided by d1 square, that is called as area ratio. And if you want to calculate the inside clearance, then Ci is equal to d3. d3 is the inner to inner, so d3 minus d1, again at most inner. Okay, this value. So d3 minus d1 divided by d1 into 100 is the inside clearance, and for outside clearance, that is C naught, is nothing but d2. d2 is the outer, so you need to calculate this value. Inside clearance you need to calculate this value, outside clearance you need to calculate this value. Okay, so this is nothing but d2 minus d4, this is the d4. So d2 minus d4 divided by d4 into 100. So this value will get the outside clearance. So area ratio, inside clearance and outside clearance. Okay, so if the area ratio is less than equal to 10%, then you can say this is means the sample is undisturbed. Sample is undisturbed, and this is standard spoon sampler. Okay, this guideline is for standard spoon sampler. It means the area ratio must be less than equal to 10% to get the undisturbed soil sample. So there are two types of soil sample. One is called an undisturbed soil sample, other is called disturbed soil sample. Disturbed soil sample again classified as representative sample and non-representative sample. So representative sample, only soil structure get modified. Means in representative sample only soil structure get modified and other things are remain same. But in non-representative sector, all three, that is structure, mineral and moisture, means structure, mineral content, moisture content, all are get modified. So this is called as non-representative sample. Okay, so we stop here. I think the foundation engineering cover. Let us see if there is some important question related to geotechnical engineering, then we definitely consider the next lecture, otherwise we wind up this.